In this video, we are discussing VSSC Electronics Technical Assessment question paper with a detailed solution which was held in 2019. The first question is, find the voltage across 30 ohm resistor in the given circuit. The answer is 45 volt. First, read down the circuit as shown in the figure. We know that by Ohm's law I equal to V by R. Here V equal to minus 40 plus 100, and the total resistance is a sum of all three, that is 8 ohm plus 30 ohm plus 2 ohm. After solving, we get current equal to 1.5 ampere. Then the voltage across 30 ohm is current 1.5 ampere into the resistance 30 ohm, which is voltage is 45 volt. The second question is, find the voltage across 10 ohm resistor in the given circuit. Answer is 6.25 volt. Here 5 ohm and 2 ohm are in parallel, and 10 ampere and 5 ampere current source are also in parallel. Hence the equivalent circuit is shown. Applying voltage division rule, the current across 10 ohm resistor will be total current, that is into opposite branch resistance divided by sum of all resistance. Here total current equal to 5 ampere and opposite branch resistance is 10 by 7 and the total resistance is 10 by 7 plus 10. After equating, we will get current equal to 5 by 8 ampere. Then we need to find the voltage across 10 ohm resistor, which is 5 by 8 into 10, which is 6.25 ampere. What will be the reading of the ammeter in the given figure if voltmeter reads 12 volt? Answer is option A, 12 ampere. Given voltage equal to 12 volt, applying Ohm's law at a 4 ohm resistor, we get I equal to V by R, which is equal to 12 by 4, which is 3 ampere. Then read down the circuit will be like this. Using current division rule, we get I1 equal to total current into opposite branch resistance divided by total resistance, which is equal to we get the current 2 ampere. How many coulombs of charge do 25 into 10 raised to 31 electron possess? Answer is option C, 40 into 10 raised to 12 coulomb. Answer, charge of 1 electron equal to 1.6 into 10 raised to minus 19 coulomb. Charge of 25 into 10 raised to 31 electrons equal to 25 into 10 raised to 31 into 1.6 into 10 raised to minus 19, which is 40 into 10 raised to 12 coulomb. A square wave of plus or minus 20 volt is given to the clamper circuit given below. What is the minimum value of the output voltage Vout? Assume ideal diode. Answer is D, minus 10 volt, plus 30 volt. Clamper is a circuit which adds DC to the given input waveform. It is also called DC restorant. The steps followed for clamper circuit analysis are: Step 1. Find the capacitor voltage in its steady state. Step 2. Replace the diode with open switch and then sketch the output. Here, from the given circuit, it is understood that diode is on for negative half cycle first. So the equivalent circuit shown in figure. Applying KVL, we get VC equal to 10 volts. Equivalent circuit during positive half cycle, that is diode is open switch. Applying KVL, we get Vout equal to Vin plus 10. As we can see here, Vin ranges from minus 20 volt to 20 volt. So consider both cases. Case 1, Vin equal to minus 20 volt. Substitute Vout equal to Vin plus 10. Here Vin equal to minus 20 volt. We will get Vout minimum equal to minus 10 volt. Case 2, Vin equal to 20 volt. Vout equal to 20 plus 10, which is equal to Vout max equal to 30 volt. Therefore, minimum and maximum values are minus 10 volt and 30 volt. What is the average value of sine Vm sin omega t over a full cycle? Option C, 0. The average value for a full wave sine wave is 0, as there is the same amount of current in the positive and negative half cycle and flowing in opposite direction. Thus it neutralizes the effect, and the average value of a full sinusoidal wave is 0. A 2-branch parallel circuit with a 100 ohm resistor in one branch A single unknown element in the other branch has the following applied voltage and current. Voltage 2000 cos 1000 t plus 45 degree volt. Total current equal to 45 sin 1000 t plus 135 degree ampere. Find the unknown element. Answer option A, resistor ആണ്. We can convert sinusoidal phasor form to different forms. Rectangular form, that is x plus jy, polar form r angle theta, Euler form e raised to j theta. Vm cos omega t plus theta in polar form can be written as Vm angle theta. According to given information from the circuit, given voltage is 2000 cos 1000 t plus 45 degree volt. The current is 45 sin 1000 t plus 135 degree ampere. From equation A, voltage in polar form can be written as V equal to 2000 angle 45 degree. Here voltage and current are in sin and cos terms. So make it as same form. Converting sin into cos, we can write sin 90 minus theta cos theta, that is sin 19 minus of 1000 t plus 135 degree equal to cos minus of 1000 t minus 45 degree. We know cos minus theta equal to cos theta. Therefore, cos 1000 t plus 45 degree. Therefore, equation 2 becomes I of t equal to 45 cos 1000 t plus 45 degree. The corresponding polar form of I of t equal to 45 angle 45 degree. Equivalent impedance is Z equivalent equal to V by I. That is 2000 angle 45 degree divided by 45 angle 45 degree. Z equivalent equal to 44.44 angle 0 degree. Since there is no phase shifter, the unknown element is resistor. A series RL circuit has a resistance of 5 kilo ohm and inductive reactance of 5 kilo ohm. What is the magnitude and phase angle of the effective impedance? Option A 7.07 kilo ohm, 45 degree ആണ്. For a given RLC circuit, the net or effective impedance is given by Z equal to R plus JXL minus XC, where XL equal to inductive reactance and XC equal to capacitive reactance. The magnitude of the effective or net impedance is given by Z equal to root of R square plus XL minus XC whole square. Also, the phase angle of the effective impedance is given by phi equal to tan inverse XL minus XC divided by R. Here, for a series RL circuit, XC equal to 0 ohms and given R equal to 5 kilo ohm and XL equal to 5 kilo ohm. The magnitude of the effective impedance will be Z equal to root of R square plus XL minus XC whole square. Here XC equal to 0. So, root of R square plus XL square, which is equal to, we get an answer of 7.07 kilo ohm. The phase angle of the effective impedance will be phi equal to tan inverse of XL by R. Tan inverse of phi by phi equal to tan inverse of 1, which is equal to 45 degree. In a three-phase balanced star connected system, the phase relationship between line voltage and the respective phase voltage is option A, line voltage leads phase voltage by 30 degree. In a three-phase load, three different impedances are connected together in a star or delta fashion. The delta in a three-phase system is formed by connecting one end of the winding to the starting end of the other winding, and the connections are continued to form a closed loop. The star in a three-phase system is formed by connecting one end of all three impedances are connected together. This is the vector diagram. This is a three-phase balanced star connected system, and this is the vector diagram. Here VPH is the phase voltage. It is taken between one of the phase and a neutral line, and the line voltage VL is taken between any two phases. That is, line voltages are VRY, VYB and VRB. From this vector diagram, we can understand line voltage leads phase voltage by 30 degree. The relationship between line and phase voltages and current in a star and delta connected network is for star connection. Relation between voltage is VL equal to root 3 VPH and relation between current equal to IL equal to IPH. For delta, relation between voltage is VL equal to VPH and for current IL equal to root 3 IPH. Fourier transform of the unit impulse del of t equal to 1 is 1. The Fourier transform of a system in the time domain is given by x of omega equal to integral minus infinity to infinity x of t e raised to minus j omega t. After calculation, we will get answer as 1. This is a spectrum of unit impulse. Note, Fourier transform of rectangular pulse is impulse and also Fourier transform of single pulse is rectangular pulse. What is the sum and carry output? 11th question. Of a full adder circuit having A and B as input and C in as carry input. Option D, sum equal to A XOR B XOR C in and C out equal to AB plus A XOR B into C in. This is a circuit diagram of a full adder circuit. A full adder circuit has 3 binary digital input, 2 input bits and 1 carry input bit, and 2 binary output, digital output, sum and carry output bit. A full adder can be implemented using 2 XOR gate and 2 AND gate and 1 OR gate as shown in the figure. This is the truth table of full adder. From the truth table, we will make K-maps for sum and carry. Then we will derive the expression for sum and carry to build the circuit. This is the K-map of sum. Sum equal to A bar B bar C in plus A bar B C in bar plus A B bar C in bar plus A B C in. Take A bar common. That is A bar of into B bar C in plus B C in bar plus take A common. A into B bar C in bar plus B C in. It is a form of x bar y plus x y bar. That is the last equation is A XOR B XOR C in. This is the K-map of carry. From this, after grouping, we will get an equation of carry equal to B into C in plus A C in plus AB. This equation 1 is not considering as we cannot combine carry circuit to sum circuit. That is extra circuit needed. So we are considering the 4 individual entries in the K-map and simplifying the equation we will get. A bar B C in plus A B bar C in plus A B C in plus A B C in bar. Taking C in common, that is A bar B plus A B bar into C in plus A B into C in plus C in bar. 0 plus 1 or 1 plus 0 equal to 1. So we get an equation of A XOR B into C in plus AB. 12th question. 2 voltage source of open circuit voltage of 10 voltage and 12 voltage with internal resistance 2 ohm and 3 ohm respectively are connected in parallel with a like terminal shorted together. What is the effective open circuit voltage of the combination? Answer option D, 10.8 volt ആണ്. The voltage source in series with the resistance can be converted into current source in parallel with the same resistance. Given voltage source are 10 volt source with the internal resistance of 2 ohm, 12 volt source with the internal resistance of 3 ohm. Here connecting two sources in parallel and like polarities. Changing into the current source, we get the circuit like the first one. Current source in parallel with the same direction are added together, so the resultant current is 9 ampere. The parallel equivalent resistance are equal to 2 into 3 divided by 2 plus 3, which is equal to 6 by 5 ohm. Final open circuit voltage V equal to 6 by 5 into 9, which is equal to 10.8 volt. This is the answer. 13th question. A train moves past a telephone post and a 264 meters long bridge in 8 seconds and 20 seconds respectively. What is the speed of the train? Answer option D, 79.2 km per hour. Speed is defined as the ratio of distance traveled to that of time taken. Velocity is defined as the ratio of displacement to that of time taken. Speed is a scalar quantity, whereas velocity is vector quantity. The equation for speed is distance by time. Given that 2 cases of train, but train speed will be constant in both cases. So by equating speed, we get the length of the train first. Consider L as the length of the train. Case 1. Train crossing a telegraph post in 8 seconds. Distance covered equal to L meter. Time taken equal to 8 seconds. S equal to L by 8 meter per second. Case 2, train crosses bridge of length 264 meter. Total length or distance covered equal to L plus 264 meter. Time taken 20 seconds. Here speed equal to L plus 264, which is the distance divided by 20 meter per second. As here both the case speed is same. So equate equation 1 and 2 we get L by 8 equal to L plus 264 by 20. Cross multiplying, after cross multiplication we get L equal to 2112 divided by 12, which is equal to 176 meter, which is the length of the train. Put the value of L in equation 1, we get S equal to L by 8, which is 176 by 8, which is equal to 22 meter per second. But in option, the answer is in the unit of kilometer per hour. So we need to convert meter per second to kilometer per hour. So S equal to 22 into 18 by 5, which is equal to 79.2 kilometer per hour. Which of the following is false for a continuous time signal? Option B is the false statement, that is sum of two periodic signal is always periodic. Actually what is that? A given signal g of t can be written as the sum of its even part and odd part. That is g of t equal to g e of t plus g o of t, where g e of t is the even part of g of t, that is g of t plus g of minus t divided by 2. G o of t equal to odd part of g of t, which is equal to g of t minus g of minus t divided by 2. A signal x of t is said to be periodic for some positive constant t naught. X of t equal to x of t plus t naught for all t. The smallest value of t naught that satisfies the periodicity condition of the above equation is called the fundamental period of x of t. The sum of two periodic functions is often periodic, but not always. Suppose that x of t is periodic with fundamental period of p and g of t is a period with the fundamental period of q, then x of t plus g of t will be periodic with a period r if p and q have both common multiple of r. So that statement is false. Fourier series states that any periodic signal x of t can be expressed as the sum of sinusoidal signals. Therefore option A and C are a true statements for continuous time signal. The built-in potential of a PN junction diode is 0.7 voltage at a room temperature. What will be the approximate value of built-in potential if the doping concentration on both sides are doubled? Assume log 2 equal to 0.7 voltage. Option B is the correct answer. As the N-type material has lost electrons and P-type has lost holes, the N-type material has become positive with respect to P-type. Then the presence of impurity ion on both sides of the junction causes an electric field to be established across the region, with the N side at a positive voltage relative to the P side. The problem now is that a free charge requires some extra energy to overcome the barrier that now exists for it to be able to cross the depletion region. The electric field created by the diffusion process has created a built-in potential difference across the junction with an open circuit or zero bias potential. The built-in potential V0 equal to Kt by Q log Na Nd by Ni square. Given built-in voltage of the diode is 0.7 voltage, that is V0 equal to 0.7 voltage. Now doping concentration on both sides are doubled, that is Na dash equal to 2 Na and Nd dash equal to 2 Nd. We know that V0 equal to Kt by Q into log of Na Nd by Ni square. New built-in potential is V0 dash equal to Kt by Q into log of 2 Na 2 Nd divided by Ni square, that is Kt by Q log of 4 Na Nd by Ni square, that is Kt by Q into log of 4 plus Kt by Q into log Na Nd by Ni square. We know Kt, that is Boltzmann constant, is 26 electron millivolt and Q is 1.6 into 10 raised to minus 19 coulomb. Substituting these equations, we get V0 dash equal to 0.7364 volt. Next question number 16. In the given circuit, D1 and D2 are 5.1 volt and 6.2 volt Zener diodes respectively, with a forward voltage of 0.7 voltage and a knee current of 1 milliampere. If Vin equal to 5 voltage, what will be the output voltage? from the circuit, we can understand the virtual ground concept. From the virtual ground concept, at the inverting terminal, the voltage is 0 voltage. The Vin is applied at the inverting terminal, so the circuit is inverting amplifier. So V output is a negative value, and at the anode of D1 we get negative value, and cathode we get a 0 voltage. Therefore D1 is reverse biased and acts like a Zener diode, and D2 will act like a normal diode. Applying KVL at inverting terminal, it is 0 volt plus at D2 0.7 voltage, knee voltage, and at across D1 5.1 voltage, that is Zener breakdown voltage, plus V out equal to 0. After equating, we get V out equal to minus 5.8 voltage. Which of the following is true about transconductance of a MOSFET? ID is the drain current. Answer is option B, directly proportional to square root of ID. Transconductance indicate the amount of control the gate has on the drain current. Mathematically, the transconductance GM is defined as GM equal to dou ID by dou VGS. It is given the name transconductance because it gives a relationship between the input voltage and the output current. The current for MOSFET in saturation is given by ID equal to Kn into VGS minus VTH whole square. Taking square root of the equation 1, we get root ID equal to root Kn into VGS minus VTH. After rearranging, VGS minus VTH equal to root ID by root Kn. We know transconductance GM equal to root ID by root VGS. That is differentiate ID, that is equation 1 with respect to VGS, we get 2 Kn into VGS minus VTH. Substitute equation 2 in equation 3, we get GM equal to 2 Kn into root ID by root Kn. When cancelling Kn by root Kn, we get root Kn in the numerator part. That is GM directly proportional to root ID. The transconductance of a MOSFET in saturation is directly proportional to the square root of ID. The 18th question. Which of the following is true about a PMOSFET? That is statement 1 is only true. That is drain current consists of holes flowing from source to drain. This is the structure of PMOS. That is VDS is negative, VGS is negative, and VT is negative for PMOS. Drain current is due to the majority carriers, and in PMOS, the majority carriers are holes, and the current flows from source to drain in the direction of charge carriers. So statement 1 is correct. For enhancement MOSFET to be on, we have to apply the desired voltage between the gate and source, which is greater than the threshold voltage. So statement 2 is wrong. Drain current in saturation region is given by ID equal to 1 by 2 mu P COX W by L into VGS minus VTH whole square. Transconductance GM equal to dou ID by dou VGS. GM directly proportional to COX. We know COX equal to epsilon COX by TOX, where TOX is the oxide thickness. COX directly proportional to 1 by TOX. Hence, transconductance is inversely proportional to oxide thickness. So, statement 3 is also wrong. Which of the following is false about compensating an operational amplifier? Actually, in an operational amplifier, negative feedback is very important for all electronic systems in terms of stability and performance. But if we can't control the negative feedback, the system becomes unstable. Buffer has a maximum loop gain with no attenuation. If the system works for unity feedback, then it works for all gains. Every electronic circuit oscillates. To avoid that, we convert multiple pole system to a single pole system. A practical op-amp is frequency dependent with many transistors and junction capacitors. If such an op-amp is used as a buffer, the output is fed back to the input and saturated. Not saturated, subtracted. Subtracting means 180-degree phase shift. For the circuit of order 3 or higher, the delay offered by the circuit for particular frequency is additional 180 degree. The circuit will oscillate at this frequency and the system said to be unstable. Frequency compensation is a technique used to solve this problem. Connect a large capacitor which will dominate the frequency response. The capacitor should give so much delay so that the delay offered by all other capacitors are neglected. Out of the four option D is the correct. False statement, which is increases the bandwidth of the operational amplifier. A non-inverting amplifier with gain 10 is realized using an operational amplifier having open loop gain 10 raised to 5. What is the feedback factor beta? Given gain equal to 10 and open loop gain A equal to 10 raised to 5. Equation of gain equal to A by 1 plus A beta. Substituting the values of gain and open loop gain A, we get 10 equal to 10 raised to 5 divided by 1 plus 10 raised to 5 into beta. After cross multiplication, 10 into 1 plus 10 raised to 5 beta equal to 10 raised to 5. After solving beta, we get a value of 99.99 into 10 raised to minus 3 second.